Hello everyone, this is Harry Lythall here again. In this video I will talk about RF safety, part 1. This video is divided into two parts, and in this part I will discuss how RF affects the human body, and I'll compare different RF technologies, including telephony. In part 2 I will talk more about the safety aspects of physical contact, misconceptions and even misinformation. So now I will jump directly into the effects of RF and put it into perspective, and then compare different types of transmissions. I have included a link to part 2 at the end of the video. So RF effects. Ionising radiation carries more than 1 billion times more energy than does non-ionising radiation. RF is at the low energy end of the electromagnetic spectrum and is non-ionising radiation, so it does not have enough energy to displace electrons from atoms and cause cancer. Exposure is related to the wavelength of the RF, and penetration becomes more concentrated or even superficial. But man-made RF transmissions have been around us for like 100 years or more. And with normal exposure there have been absolutely no recorded ill effects, no illnesses or injury to humans. And this is supported by the researchers and doctors employed by the World Health Organization, the WHO, and the US FDA. The only proven effects of RF radiation to the body are heating. Your teeth don't fall out, and you do not glow in the dark. The accepted danger level threshold according to the WHO is about 100 watts. This figure though, it varies greatly with frequency, how big you are and which part of the body is subjected to RF. RF causes power dissipation, or molecules to become more agitated, which in turn causes the heating. Now let's put this into perspective. Your body generates around 350 watts of heat. So if you're cuddled up close to your loved one, then you can expect to absorb around 100 watts of heat from your partner. You may only get about 30 watts from cuddling up to a big dog, and even less from the cat. Now it's a fact that the strongest energy source to which humans are exposed today is the sun, which is almost 150 million kilometres away from us, but it manages to radiate the upper atmosphere with 1,400 watts per square metre. Now at sea level, at the equator, on a clear day, we're exposed to about 1,000 watts per square metre. Much of that energy is ultraviolet, visible, infrared light and other forms of radiation which are far more dangerous than RF. The sun causes body heating, skin discoloration and can even cause skin cancer. Now with 10 times the accepted safety threshold, could this mean that the sun is illegal? I suppose any legal case would have to wait until God or his legally appointed representative turns up to answer any charges. But what about exposure to RF? Now you have got an idea as to how much heating your body can tolerate, so let's look at RF exposure. If you are extremely close to an electromagnetic radiation, then you may get some unmeasurable temperature rise. But blood circulation dissipates heat all the way around your body. Now low frequencies have a wavelength many times longer than the human body, so that all the energy will simply pass through you with little or no effect whatsoever. This, by the way, is why very low frequencies can communicate with submarines underwater. It's not until you exceed about 100 megahertz that the body starts to absorb RF. So if you stood beside a single antenna radiating, say 500 watts, then you may possibly pick up as much as 100 watts if the frequency is really high and if you were extremely close. RF below about 10 MHz will just pass through you without any effect whatsoever. Over 300 MHz will be dissipated more and more with higher frequencies, penetrating to even shallower depths. Now, as frequency increases, the signal losses in the air will also increase, making the received power level even lower. And this negates the increased absorption with frequency, reducing the field strength per square metre. If the frequency to which you are going to be exposed at, say, 1 kilometre distance increases from, say, 100 MHz to 1000, then the field strength will fall by about 90% due to the increased path loss. At 5 kilometres, the field strength will fall by 99% due to the signal losses. For comparison, I'm going to ask you to hold up a half wavelength antenna 1 kilometre away from a transmitting antenna, and I will just screw up the radio transmitter power just to get 1 watt into that antenna that you are holding. How much power do I need to transmit to give you that 1 watt? 100 MHz broadcast antennas are mounted on towers, maybe 50 to 100 metres high and radiating horizontally in the air. The strongest signal to which you can be exposed about 1 kilometre away from the antenna to get inside that directional beam. The power you will experience due to path losses will be about 5 times 10 to the minus 10th, or half a picowatt of power. Now, to get anywhere near a dangerous level, the FM transmitter power would have to be increased to about 1.5 times 10 to the 9th watts, or 1.5 gigawatts, which is more power than the output from a nuclear power plant. They don't make radio transmitters that are all that powerful. Now, let's go down to the lowest terrestrial TV frequency, 470 MHz. The power would have to be raised to 4 times 10 to the power of 10 watts. That's 40 billion watts, which is the same as 40 nuclear power stations. And terrestrial TV is about the worst case scenario, since some TV transmitters can have an output power of up to 1 million watts. But since TV antennas are typically up to 600 metres above the ground, located on hills, out in the countryside, and the output is directed horizontally away, then you would have to go about 5 kilometres, maybe 10, maybe more, to get into that beam of radiation. OK, let's go up in frequency now, and we'll go up to 900 MHz GSM. The transmitter power would have to be increased from 100 watts to 1 times 10 to the 9th watts, which is 1 billion watts, or the full output from a nuclear power station. At 2.4 GHz, that's LTE UMTS, transmitter power would have to be increased from 100 watts to 10 times 10 to the 10th watts, which is 10 billion watts, or the full output from 10 nuclear power stations. At 40 GHz, that's the 5G, transmitter power would have to be increased from 240 watts to 3 times 10 to the power of 12 watts, which is 3 terawatts, or the combined output from 3,000 nuclear power stations. Given that telephony transmitters are typically in the range of only 5 watts, maybe up to 240 watts, there is absolutely no way any telephony or broadcast transmitter, digital or analogue, can have any effect on your body. And since digital telephony is pulsed with a duration maybe as little as 1/100th of a second, then the received power will be only 99% lower than the examples I've just given you. So as you can see, all the hysteria about RF power levels in public is totally unfounded, and by far the safest RF signal levels are 5G. 5G also has that 240 watt maximum shared between typically 64 antennas, so there's no way you could get near any single antenna radiating more than 3.5 watts, even if you broke into the radio site and stood beside an antenna. But practically the RF power levels in the air to which you're exposed are not even microscopic. The word microscopic is an understatement, to say the least. Nanoscopic would be a better word, if the word exists. And when we're talking about 5G, you would have to invent the word, picoscopic. These are really, really small signal levels. So, in this video, part 1, I talked about the effects of RF on the human body. I talked about how much RF you can tolerate and the microscopic amounts that are available in the air. I compared different types of RF communications technology, with 5G being by far the safest. But I do urge you always to question everything you see or read. Visit the Doctor Who pages at the World Health Organization and read for yourself the published research. Never believe any of the scaremongers who try to tell you that exposure will make you sterile, and nor will it burn you into a small crisp. So I hope that you have found this video, part 1, interesting. You can find the link to part 2 in the description, and also in the link to the left on the screen. And please feel free to leave any comments below and click on some of the buttons down there. All comments are greatly appreciated, whether they are positive or constructive. Also, the more likes I get, so the more of these videos I will produce. Having said that, I want to thank you all for watching me today. And I wish you very best regards from myself, Harry Lythall, SM0VPO, amateur radio call sign, an Englishman in Sweden.